Imagine making your AI smarter just by hitting Ctrl-C and Ctrl-A without it costing you a single second of extra wait time. It sounds like magic, but Google researchers say it's actually just math. Welcome to our podcast, Artificial Intelligence. Papers and Concepts, curated by Dr. Satya Malik. Now, before we jump into this absolutely wild paper, I do need to make a quick disclosure. Even though we're bantering and chatting like old friends, both my voice and the voice of my expert co-host here are 100% AI generated.
That's right. We are avatars of code, but the research we're about to dig into is very, very real. And honestly, it's quite surprising.
Surprising is an understatement. Today we're looking at a paper called Repetition Improves Non-Reasoning LLMs. It's fresh out of Google Research 2025 from Yaniv Leviathan, Matan Kalman, and Yossi Matthias. The title, it kind of gives the game away, doesn't it?
It does, but the implications are so much deeper. The real mission for us today is to explore how this bizarrely simple technique, literally just repeating the prompt, solves a really fundamental structural limitation in how large language models process information.
I love it. Just do it twice. It feels like the classic turn it off and on again advice for computers. But okay, to get why this works, we first have to understand why LLMs are broken in the first place. Or maybe broken is too strong.
Limited is probably a better word. You have to remember that most of the big models we use, GPT-4, Gemini, Claude, they're trained as causal language models.
Okay, let's unpack that. Causal, like cause and effect. What does that mean for an AI in this context?
It means they process text in a straight line from left to right. So when the model is reading the first word of your prompt, it has absolutely zero idea what the 10th word is going to be. Past tokens, the words it's already seen, can't attend to future tokens.
So it's like reading a sentence through a tiny little slit in a piece of paper. You only see what you've already passed over.
That is a perfect analogy. And this creates a huge problem for context. For instance, imagine I give you a multiple choice question. If I say, what's the capital of France, and then give you the options, you know what you're looking for. It's easy.
Right. What is the capital of France? A, B, C, D. Simple enough.
But what if I flip it? What if I say A, London, B, Berlin, C, Paris? Question, which of these is the capital of France? When the model reads London, it doesn't know what the question is yet. It's just processing the word London in a total vacuum.
Oh, I see. So by the time it actually gets to the question, it has to somehow look back at those options that already flew past. But you're saying that's hard for it to do.
It can't look back, sure, but its initial processing of those options was completely uninformed. It didn't know what to pay attention to. The computational focus wasn't on the right features of those words because the main context, the actual question, hadn't even arrived yet.
That sounds incredibly frustrating. It's like listening to a long story and only at the very end realizing you were supposed to be remembering everyone's middle name. You heard them, but you didn't store them right.
That is exactly it. And that brings us to the paper solution, which is it's shockingly simple. They propose transforming the input from just query to query.
Wait, what? They just pasted in twice.
Oh, that's it.
So if I asked, what is the capital of France? The input literally becomes, what is the capital of France? What is the capital of France?
Precisely that.
And this works. It doesn't just, confuse the AI.
It works remarkably well. And before I get into the mechanics of why, I think we should take a quick moment to thank our sponsor for making this deep dive possible.
This podcast is sponsored by BigVision.ai, a consulting and product development company that helps companies of all sizes build computer vision and AI solutions. You can reach them at contact@bigvision.ai. Okay, we're back. We're talking about prompt repetition, literally copy-pasting your prompt to make the AI smarter. So explain the magic to me. Why does saying it twice fix this uninformed processing problem?
It goes right back to your slitted paper analogy. When you repeat the prompt, the tokens in the second repetition can look back at every single token in the first repetition.
Okay. So the first time through, the AI is kind of stumbling around in the dark, just getting the lay of the land.
Exactly. But the second time through, it has full visibility. It effectively simulates what we call bidirectional attention. The model can process the start of the second prompt while fully attending to the end of the first prompt. It knows the whole context before it even starts.
That's fascinating. It's like giving the AI a quick practice run before the real test. It reads it once to get the gist, then reads it again to actually do the work.
You got it. It turns the prompt from, a stream of surprises into a reference document. The first copy is the memory bank, and the second copy is the active processor that's querying that bank.
So does this really work in the wild? Or is this just some theoretical quirk they found in a lab.
Oh, it's very real.
Mm.
The researchers tested this on 7 popular models. We're talking the big ones: Gemini 2.0 Flash, GPT-4o, Claude 3, DeepSeek V3, and they threw a whole suite of benchmarks at them: ARC, OpenBookQA, GSM8K, MLU Pro.
And the verdict?
So they defined a win as a statistically significant improvement. Across 70 different test combinations, prompt repetition had 47 wins and 0 losses.
Hold on. 0 losses. That can't be right. There's always a trade-off in computer science.
And that's what makes this paper so important. 0 statistically significant losses. It either helped or it did nothing. It never made things worse. I mean, that alone is incredibly rare in AI research.
That is just wild. Okay, so 47 wins, 0 losses. Where did it win the most? Was it that options first scenario we were talking about?
That's exactly it. They specifically looked at that problem. Normally, LLMs take a huge performance hit when you show them the options before the question. But with prompt repetition, that gap almost completely vanished.
Because it gets to read the options, then the question, and then in the second go-around, it reads the options again, knowing what the question is.
Right. It puts them on equal footing, which is huge for anyone feeding messy data into an AI,
All right.
You're scraping websites or something. You don't always control the order.
Yeah, that's a great point. But what was the big wow moment?
For me, it was a custom benchmark they made called Name Index.
Oh, I saw this one. This is the needle in a haystack thing, right?
Sort of. They give the model a list of 50 random names. Then they ask a simple question. What is the 25th name in the list?
Which sounds easy for a computer. That's just counting.
You'd think so, right?
Hmm.
But for a causal LLM, tracking position is notoriously difficult. Remember, it doesn't see a numbered list. It sees a stream of vector embeddings. So on the baseline test, Gemini 2.0 Flashlight, it got this right only 21.33% of the time.
21%. That's awful. That's basically just guessing.
It's terrible. But then, they just repeated the prompt, pasted the list, and the question in twice. The accuracy jumped to 97.33%.
Whoa, from 21 to 97, just from saying it twice.
Yes, because on that second pass, the model has a reference copy. It can align the position of tokens in the second sequence against the first. It creates this kind of structural scaffolding that makes these retrieval tasks incredibly easy.
That is mind-blowing. Okay, but I can hear the skeptics already. If I double the input text, don't I double the cost? And more importantly, don't I have to wait twice as long for my answer?
A very, very valid concern. This is where we have to put on our engineering hats.
Right. I mean, a 100,000-word prompt becomes a 2,000-word prompt. That has to be slower. My API bill just doubled.
So let's talk speed first, because that's the most counterintuitive part.
Yeah.
The short answer is no, it doesn't really make it slower for the user.
How is that even possible? More text has to mean more
We
processing.
have to distinguish between the 2 stages of an LLM, prefill and generation.
Okay.
Generation is when it writes the answer. That's serial, 1 word at a time. That's the part you see typing out, and that's the slow part. But the prefill stage, when it reads your prompt, that's highly parallelizable.
Parallelizable, meaning it just gulps it all down at once.
Essentially, yes. The GPUs can process that entire chunk of text, even if it's repeated, in one massive parallel crunch. So whether you feed it 500 tokens or 1,000, the wall clock time for you, the user, is almost identical.
So the reading part is super fast no matter what.
Within reason, yes. And the paper found no increase in user-facing latency. And crucially, the generation length didn't change. It gave the same concise answer, just a more accurate one. You get better performance for the same wait time.
Okay, that's the free lunch on time. But what about the cost? More input tokens still costs more money.
It does. That is the trade-off. But think about the alternative. For high accuracy, you might use chain of thought prompting, right? Think step by step.
Yeah, and then the model spits out this huge paragraph of reasoning before the final answer.
And you pay for all those output tokens. And output tokens are usually way more expensive than input tokens, and they take much longer to generate. So prompt repetition shifts the cost from the slow, expensive output to the fast, cheap input. It can actually be cheaper.
That's a really clever way to think about it, but let me play devil's advocate again. Are we sure it's the repetition itself? Maybe models just like longer prompts, more thinking space?
A great question. And the researchers thought of that too. They ran an ablation study. They tried a padding method. Instead of repeating the prompt, they just added a bunch of periods, a bunch of dots, to make it the same length.
It's just jump data.
Exactly. Just to see if raw length was the magic ingredient.
Yeah.
And the result?
Nothing.
Nothing. No improvement at all. The padding did nothing. It proves the gain comes from the specific information being available for attention, not just the size of the context window.
It's not the length, it's the content. Okay, got it. Did they try any other variations, like if twice as good is 3 times better?
They did. They tested an by 3 variant.
Yeah.
For most standard tasks, it was about the same, diminishing returns. However, for those really hard retrieval tasks like name index or another one called middle match,
Yeah.
the by 3 version was substantially better.
Middle match.
Yeah, where it has to find the item physically located between 2 other items in a list.
Yeah.
Very precise. The by 3 repetition made it super robust at that. It suggests for really complex retrieval, more redundancy really does equal more precision.
It's like when you're checking a long credit card number. You don't just check it once. You check it twice, maybe 3 times, if it's really important. The AI is doing the same thing.
Exactly. But there is a very important limit here, a key nuance in the paper. This technique is specifically for non-reasoning models.
Ah, right, that's in the title. What happens if you try this with chain of thought, with think step by step?
When they tested that, the results were pretty much neutral. 5 wins, 1 loss, but mostly ties. No real benefit.
Why not? You'd think it would help everything.
Well, think about what chain of thought is actually doing. It forces the model to write out its logic. In doing so, it's already repeating the important parts of the prompt in its own output.
Oh, so it's already doing its own repetition.
Precisely. The reasoning process itself is a form of self-correction and reattending to the information. So giving it the input twice is just redundant at that point.
That makes perfect sense. So this is really a drop-in upgrade for when you want a fast, direct answer without all the preamble. It gives you the accuracy of a reasoning prompt without the latency.
Correct. And that's why the deployment side of this is so interesting. As the authors point out, this doesn't change the output format at all. So developers could just implement this silently on the back end.
Right. If I'm building a chatbot, I can just have my code automatically double the user's prompt before it hits the API. The user never knows. They just get a smarter answer faster.
Exactly. It's a back-end optimization. And looking ahead, the authors suggest you could fine-tune models to specifically expect repeated prompts. Or even optimize the memory, the KV cache, to just discard the first repetition after the tree fill.
Oh, to save memory. The model realizes, okay, I've seen this. I only need to keep the second copy active.
You've got it. That would make it even cheaper computationally. They even floated the idea of applying this to images. Multimodal repetition.
That would be wild.
Oh.
Look at this photo. Now look at it again. Now tell me what you see. It feels so human.
It really does. It mimics how our own eyes work. With saccades, we dart around, scanning the same scene multiple times to build a mental picture. Single-pass processing is actually pretty unnatural when you think about it.
You know, we started this whole deep dive talking about this as a mathematical trick, but the more we discuss it, the more it just feels like a lesson in patience.
How do you mean?
Well, we always think less is more. Brevity, efficiency, the shortest prompt possible. But for these AIs, it turns out more of the same is what creates real understanding. It's literally the digital version of rereading a paragraph to make sure you got it before you answer a question.
That's a fantastic synthesis. In our rush for speed, we forget that real comprehension requires dwell time. The AI can't dwell in time, so we let it dwell in space by giving it the prompt twice.
Which brings us to the end. But before we sign off, I think you have a final thought for our listeners.
I do. If AI models, these massive logical machines, perform so much better when they're forced to simply read the prompt twice, how much of our own human misunderstanding is just caused by us rushing to answer after reading something only once?
Ooh, that is definitely going to stick with me. A huge thank you to the researchers, Leviathan, Kalman, and Matthias for this incredible paper. And thank you to everyone for listening to this deep dive. If you enjoyed it, please subscribe to the podcast. We are always digging up the latest papers and concepts to make you the smartest person in the room.
Until next time, keep learning.
Yeah.